I'm CK. Tonight we have another soldering practice kit from Amazon. This is again from MiOYOOW. It's a do-it-yourself soldering kit, Wind Chime LED. We'll see how it comes out. Might be pretty much fun. We'll see how good it is as a learning tool. And I hope you enjoy the video. Here's the package. See what we got inside. We have some plastic, maybe acrylic, plastic panels with some protective material on them, which we'll be peeling off later. Got a bag with electronic parts and then a bag with more parts. Here are a couple more plastic panels. These are the side panels. A QR code. I assume that's going to take us to the build guide, which is good. We've got QC sticker, May of 2021, so it's been sitting on a shelf somewhere for a while. I'm filming this in August of 2022. And then a whole bunch of hardware, some spacers, screws to put the case together, but we'll leave them all in that bag for right now. Let's look in the electronics bag. Start with the circuit board itself. As you can see, there's a whole bunch of LEDs. Not as many as some. That Ferris wheel over to my side, that's got 120 surface mount LEDs, and I did that a couple of weeks ago. You can look at that video if you want. That's harder than this, so not too worried about it. And a bunch of resistors. The values are not listed on the board, are not printed on the board. So we've got 1, 2 transistors, a couple of caps, a switch. That'll be the on-off switch. Power connector is here. So basically, we're just going to be oscillating between two positions with the the transistors here. Okay. That might be kind of fun. Obviously it doesn't make any noise because there's no speaker output. And the board looks pretty good quality. The solder points are all through-hole plated, which is very good. So that's nice. I'm trying to see, this does not have a sub-manufacturer. It's got a part number, TJ56162, but it doesn't have, in English at least. I'm sure these Chinese characters say something, but I am not competent in Chinese, so I can't read them. Let's see what the piece of paper says. And it's got LEDs stuck all over it. I think there are LEDs everywhere for this kit. And I'm sure they've given us spares. They typically do. We'll take a look at them in a minute after we look at this. And this is the parts list with all the positioning. So with this information right here, you could build it without the build guide, because this is just saying all the 1K resistors go in these slots, 68K resistors in that slot. And the only thing we don't know is the diodes, because they're listed in 3 places. I assume that's 3 different colors. Oh, and we could figure that out, because there's 4, 9, and 80. So, as I quickly glance at the bag, the 80 is going to be the blue ones. Looks like the greens may be the 4 and the reds are the 9, but I'd have to count for sure on that. So theoretically you could do this without the build guide. And on the back here we have schematic, and again it's a pretty simple schematic. Power connector, power switch, and then this oscillator circuit with the 2 capacitors, 2 resistors, and 2 transistors flip-flopping back and forth to power alternate sets of LEDs. I'm trying to see where they get set up. Oh, there's L1, L11. Okay, that's where it continues from. Okay, so this goes to here, L01 goes to there, L0 goes somewhere, but you can figure it out from this. So you don't have to go to the build guide if you don't want to. We will, just for completeness sake. But let's look at the rest of the bits and pieces. I'm going to dump this all out. USB power, so 4.5, 5 volts, whatever. Then we've got a bunch of resistors, and again with LEDs attached to them, because LEDs are everywhere in this kit. And these are all the same. These are all the 1Ks. I'm going to set that right there just for now. Another inspection sticker. And this was done in April of 2022, so half the kit was done, processed at a different time as the other. Here's the power switch. Click, click. Pin's a little bit bent, but not bad. Power connector. The electrolytic caps. Put those over there. 1 transistor. Couple of other, these are the 68K resistors. Other transistor, and then all these LEDs. Let's take a look at the LEDs to see what they look like. So I'm going to power up my voltmeter, put it in continuity mode, which is the mode where when you check something for continuity, like this metal tray, it beeps to tell you that it's got continuity. Well, that means there's a little bit of power going through these leads. So I'll put the positive lead there and the negative lead, and oh, that's a pretty blue. Now, if I were making this kit, seriously, if it was a kit that I wanted to put in a really good case or something like that, I'd go through and check all the LEDs so I didn't have to rework anything after I turned it on. But for what we're doing here, just as putting this together and exploring it a little bit, I'm not too worried about that. Oh, that green is not very bright. It's less bright than the red and the blue. Oh well. That's the parts. So we're ready to put it together. I'll get the soldering iron heated up and find the build guide, and we'll start putting this thing together. The QR code didn't resolve. However, on the Amazon product page, there's a link to the manual, and here it is. It talks about it. Then installation tips. Please be patient when you put it together. And then a bunch of pictures, which is really good. This has been true of most of MiOWOOW's kits. They have lots of good pictures to help you get through it. How to identify diodes and put them in, correctly and all that. So it looks pretty straightforward. And the little acrylic case to put it in. So we'll start with the resistors, as always. So we'll get our circuit board on the little rubber solder helper pad, high temperature silicon rubber. Your soldering iron won't burn it. And I made this from silicon rubber, 2-part silicon rubber I got from Amazon. I have a build video of how to do this. I had never done it before, and it turned out to be really simple and really useful. So if you would like something like this, look for that video, give it a glance, and you'll see that you can probably do it just as easily as I did. We're going to start with the two 68K resistors, which go right here and right here, which are setting some of the timing speed. Now the first thing you do when you're approaching a new kit, new manufacturer, you want to see how much you have to bend the leads, how close to the body of the resistor you need to bend. And this is laid out, so you want to bend them as close to the body as you are able, and then they'll drop right in. The other thing I'm doing right here is you want to come up with a consistent way to put your components on the board. For example, I put resistors on the board with the highest value stripe up or to the left. So in this case the blue 6 stripe is up, and for these resistors over here, when I put the 1Ks in, I'll be putting the brown stripe to the left. You don't have to do that. It's not at all necessary. What it does is it just makes your life easier later on if something doesn't work and you have to troubleshoot it. You can quickly glance at the board and see whether you've got your resistors, the right value resistors in the right place, without having to look at it and say, oh, which end do I start looking from? If you always put them the same way, you will never have to worry about, am I reading it forwards or backwards? Again, you can do it another way. You can put the primary color band down to the right. As long as it's consistent and you know the way it's laid out. So let me put a couple more of these on. And right now I'm going to go ahead and solder these just so we can get a feel for how the solder flows on this board and how easily it's going to be to do everything. It's flowing very well, and because these, as I mentioned, these holes are plated, it's all the way through the board. The solder is wicking down into that hole, making sure that there is a good connection. Possibility of a cold solder joint or a bad solder joint is very much reduced with through-hole plated circuit boards. So that's those. All these 1K resistors are to reduce current going through the LEDs to a reasonable amount. Let me trim these leads off. Now there's nothing much more to say about the resistors, so I'm going to put the replay into fast motion, and you can watch all the resistors fly onto the board. all the resistors are on. Now we'll put the two 9014 transistors on. Here and here. Flat spots facing outwards. Little tip I use, I always do the middle pin on a transistor first, and then the outer two. It seems to make it a little bit less likely that I will bridge any of the connections. You don't have to do that, of course, just something I do. I'm not going to cut those leads right yet. I'm going to put the two capacitors in because they're a key component of the oscillation rate for the wind chime thingy. So clearly marked, a plus symbol, and shade for the negative side. So the long leg goes in the plus side and the stripe side goes to the shaded side, making everything really easy. It's easy if you can find the other capacitor. Where'd you go? Oh, I put it right here. I'm going to put the other components on that are not LEDs right now also, just because I'm here. So here's the switch. And again, one pin's a little bit bent, but not badly. And there's a small notch mark here on the board. And there's a small notch mark here on the switch. So they've got to be lined up or facing each other. Let's see. And that's not too snug. So what I'm going to do is I'm going to rest it on a couple of fingers. And I'm going to solder one pin, let it cool, pick it up, take a look, make sure it's flat, and as you may be able to see, it's not quite flat. So what I'm going to do is press on it, heat that pin up again, the solder heats up, let it cool, and it's now flat to the board. Now we'll do similar thing with the power connector. Can't put it on wrong, or it would be very difficult to put it on wrong, the way the pins are offset. Now let me make sure that's flat. Oh, that's very flat. Now I'm going to go ahead and solder all the pins of the 6 components I've put on. Now the next big step is putting all the LEDs on. Now they do have a nice little description of how to identify LEDs and use them. Longer pin is positive. There's a flat spot on the negative side. And they even describe how you can look inside if you can see through the plastic of the LED to see that the bigger side is the negative cathode side. So many ways to identify, and then this also says how you can test the LED for power. So now we're going to put 3 green LEDs at the top, and the square pad is always positive on this board, so the long lead goes in the square pad. And I'll go ahead and do these 3 while we're here. I'm going to do, and you can do basically the same thing as I did with that switch, is to make sure these are flat on the board, solder one leg. Then you don't even really need to look, just press firmly with your thumb and reheat that, and you saw, I think you probably saw the leads move a little bit. It flattened itself out onto the board. If you care about that, I'm not going to be doing that for all these LEDs, because I don't care if it's a little raggedy. That's just me. If this is your first time, your first kit, or if you want to put this in your room as a real good display piece, you'll probably want to get all the LEDs firmly flat against the board. And yeah, it's just solder one lead, heat up the solder point again while holding the LED firmly to the board with your thumb, and that'll be good enough. As with the resistors, there's not a whole lot to say now that we've talked about what I wanted to talk about here. Oh, the only other thing is we want to make sure we get the red LEDs in the right places. And unfortunately, this doesn't actually give the numbers, but this gives the numbers for the solder location of these 8 LEDs, and they will go in D55, D62. So they will go D55, 56, 57, 58, and then going backwards 62, 61, 60, 59. So that's where those will be going. But again, I'm going to go back into fast replay as I put 80 more LEDs on this board. Okay, so that's all the soldering done, and we have, geez, 2, 4, 6, 8, 10, 12, 14 or so blue LEDs as spares. Now we're going to put together the case, and I peeled all the film off it off camera because it would be too tedious to watch me fighting with film on camera, so I spared you that. Now we're going to take the bottom. We have a bottom piece and we have a front piece. We're going to take the back piece and we're going to first, I think we're going to, let me double check this so I can see. Yeah. We're going to put these brass spacers on the back. Oop, one's already got a screw installed. Huh. I don't even think that's the right screw because it's not screwing in. That's for one of the side pieces. So we'll take this screw, and you don't need to tighten it that much. I mean, obviously it's not going anywhere. Oh, I'm sorry. I'm going to do one other thing before we go any further. What I always like to do when I get done soldering is I take an index card and look at all the solder joints to make sure nothing's bridged, shorted, or in some cases missing. and I use an index card to do this, so I'm only looking at one line of solder points at a time. I'm not trying to scan the whole back of the board all at once. But it's a good idea. I certainly, even to this day, will get to the end and take a quick look and find I haven't soldered all the connections, particularly on a board like this where there are so many. Also on a board with a lot of sockets. Now I'm going to get my little polishing rag and get my grimy fingerprints off the back. I wonder it's got these holes. Oh, I know why it's got those holes. We'll get to that. And we'll put the back piece on. Won't tighten that all the way yet before I get this other corner in. Now that I've got two corners in, well, obviously I did that wrong. Obviously, look at that, how cattywampus that is. This is not square, it is rectangular. I didn't even think to look at that. So the way you do these, you can see it's got a little cross shape, and this little, the nut goes in like so, and the screw will come up from the bottom and capture it. It can be a little tricky the first couple of times you do this, or I should say anytime you do this. I mean, I still don't always do it the best way, so I will use a pair of tweezers and put the nut in there. Oops, and see, it fell. I pushed it all too far in. I didn't push it far enough in. Again, these can be a bit of a pain. Ah! And now I'll bring the screw up through the bottom. If I can get my fingers set right. Oops, and the screw fell out, a nut fell out again. Again, these are a pain. Fell out again. I do these so often. I need to come up with a better way for me to manage this. I spend more time on these captive nuts than I do... Ah, God! I spend more time on these semi-captive nuts than I do soldering the actual product together. Actually, changed my mind. I'm gonna freaking Loctite it together. I'm not gonna mess with these tedious little screws and nuts. Okay, so that's together. Again, I'm not too worried about it having to be Loctited together. Now we'll see what it looks like. Let me set up my power cable. Make sure I can reach it. Let me turn off this light. Adjust the... Now one thing, they didn't give us a cap for this power switch, so it's not too easy to get to. Where's my... Let me use a screwdriver to... my pokey thing to poke at it. We'll turn it on. And there it goes. The bell goes, swings back and forth. The speed, it's going a little fast. The speed at which it's operating is controlled by these two capacitors and those two resistors switching these two transistors. You can look at the schematic on the paper they include and also look up online for a 2-oscillator flip-flop, and you'll see this. Looks like we've got one bad red LED, but that's it. The greens are very weak. Can you even see them on camera? Can't even, yeah, a little bit. So that's what it does. It's a good kit for solder practice, absolutely. Good for learning too, because the circuit's relatively simple and you can see how it actually works. This case stinks. I really dislike these types of cases and I get frustrated by them. But overall, it's a good kit. If you are working with a youngster on this, they will need to have help putting this case together, unless you want to do what I did and just glue it together, brute force it together. But for the price and for the value of learning how to solder well, it's a fine kit. Thanks for watching the video.